Bright Duty. Every student matters.
Hello students, my name is Sanjay Jain. Today we will do the optional exercise of the chapter triangles of class 10th, right. So as I told you that this exercise may not be important from examination point of view, but for conceptual clarity we will do it, and I will take the liberty to not write all the steps, right, so that you can write the steps yourself, but you understand it here. Okay, so let us start it with first question here. Although it's not a question, it's a theorem that if PS is the bisector of angle QPR, that is these two angles are equal, right? Prove that QS by SR is equal to PQ by PR. This is also known as internal angle bisector theorem, right. So we will prove it once, but you have to memorize the result also, because if you are taking some higher examination like any competitive examination based on class 10 syllabus, then it will be very useful for you. Okay, so the first thing that I am going to start with is, let us assume this angle as theta. So this angle will also be theta because it is given in the question that PS is the angular bisector of angle P. Okay, so now to prove PQ by PR equals QS by SR, what I am going to do here is I'll draw a line, I'll extend this line QP, okay, and I'll draw a line from this point R parallel to SP. Okay, let us say this point is M. All right, now this line is parallel to PS, so draw RM parallel to SP. This is the construction that I am doing here. Now look at the question. If these two lines are parallel and PR is transversal, then what will be this angle? This angle will also be theta because it is alternate interior angle, right. These angles are alternate interior angles, so they are equal. Now PS is parallel to RM by construction, so this angle here, this angle will be equal to this angle. Why? Because this is a corresponding angle, okay. This is corresponding angle of this angle here, and these two are alternate interior angles, right. Once you understand this much, now if you focus on this triangle, you will see that the base angles of this triangle are equal, hence the opposite sides to these angles are equal because this is an isosceles triangle. So what can you say about sides PR and PM? These are equal sides opposite to equal angles in an isosceles triangle. Now if this much is clear, then the theorem should be clear to you in a moment. Now see, in triangle QRM, PS is parallel to side RM. So by BPT or basic proportionality theorem or Thales theorem, what can you say? You can say that QP divided by PM is equal to QS divided by SR, right. This is the basic proportionality theorem. If you don't understand it, go to the very first lecture of this chapter, triangles. You will understand BPT, and then you come back, you will see that if we draw a line parallel to a side of the triangle, then this parallel line divides the other two sides in equal ratios. So QP by PM is equal to QS by SR. Now what is PM? PM is nothing but PR. PM is equal to PR. So let me replace PM by PR. QS by SR, hence proved. Right? This was as simple as this. Okay, I have not written any steps, so that I don't want you to memorize the steps, or I don't want you to cram this solution. I have given you the solution, now you do it yourself. Now what is the result? That let us say if there is any triangle, let us change the name of triangle ABC. Okay, so if I take an angular bisector of angle A, let us say AD is the angular bisector, let these angles be alpha and alpha. So what can I say about this ratio AB upon AC? AB upon AC, it will be equal to BD by DC, ratio of corresponding segments, right, made by this angular bisector here, BD by DC, and it will not be the other way around. Some of the students might make this mistake that AB by AC is equal to DC by BD. No, right? If you write AB by AC, then you take this segment first, right, corresponding segment of AB, BD by DC. So this is the correct relationship. For that matter, if you draw the angular bisector of angle B, let us say this angle is beta and this angle is also beta and this is E. So what will be the ratio AB by BC? It will be equal to AE by EC, AB by BC, AE by EC. So take care of the corresponding segments. So this is about internal angle bisector theorem and its proof, right? So this was my first question of this exercise. Now D is a point on hypotenuse AC of triangle ABC, okay, such that BD is perpendicular to AC, right, DM is perpendicular to BC, okay, DN is perpendicular to AB, okay. Now first thing I need to prove is DM square is equal to DN into MC, right, DM square is equal to DN into MC. The first thing I notice here is that DM is perpendicular to BC and NB is also perpendicular to BC. So DM and NB are parallel, okay. Similarly, DN is perpendicular to AB and MB is also perpendicular to AB. So I can say DN is parallel to MB, okay. And these collectively tell me DN BM is a parallelogram, and I see that this angle is 90 degrees. So even if one angle of the parallelogram is 90 degrees, it becomes a rectangle. So DN BM is a rectangle, and if it is a rectangle, then the opposite sides DN and MB are equal, DM and NB are equal, right. This I could have written on the basis of it being a parallelogram also, right, but I wanted to specifically mention that it is a rectangle because all the angles here are 90 degrees, okay. So DN and MB can be used interchangeably here, and DM and NB can be used interchangeably. So I require DM square, DN and MC, okay. Alright, so let me focus on these two triangles. Why I have chosen these two triangles? One, I require DM square. Second, I require MC, which is here. Third thing I require is DN. So DN is this, but it is also equal to MB. So if I choose these two triangles, all the required sides are present here in these two triangles. So in these two triangles, this angle M is 90 degrees and here this angle M is 90 degrees, right. And if I say that this angle is alpha, what can you say about this angle here? This angle is 90 minus alpha. Why? Because if I take this as alpha, this angle is 90 degrees. So the third angle will be 90 minus alpha for the sum to be 180 degrees. I am using the angle sum property of triangle here. right? So if I take this as alpha, this angle will become 90 minus alpha. And what can you say about this angle? If this is alpha, this is 90, then this angle will obviously be 90 minus alpha. And now this complete angle is 90 degrees and the part of this angle is 90 minus alpha. So the remaining part will obviously be alpha. Okay. So now if you see, these two triangles have all the angles equal. Okay. You just take care of the correspondence, because you can say now that by angle similarity, triangle CMD is similar to. Now you need to take care of the correspondence and then you can comment. When I say CMD, C is angle alpha, M is 90, then 90 minus alpha. So here alpha 90, 90 minus alpha. So the correspondence will be DMB. Right? Triangle CMD is similar to triangle DMB. Now I require DM square. So I am looking for DM. DM by BM is equal to, here again I have DM, so I will use CM from this side, CM by DM, right. Now if I cross multiply, DM square is equal to BM into CM. Now BM I can replace by DN, right. BM and DN are equal, so I can replace it by DN so that I can prove this result. So let me replace it by DN. Now the first part is proved. Now let us look at the second part. DN square is equal to DM into AN. So now square of this side, that is DN, I require on the right hand side DM and AN. So AN is present here and DM. So this is DM, but NB is also equal to DM. So I require this side. So I will be using these two triangles. Okay. So this angle is also 90, right? And see, if this angle is 90 minus alpha, what will be this angle here? This angle will obviously be 90 minus alpha, right? And this angle is 90 minus alpha. This angle is 90. So what will be this angle? This angle will obviously be alpha. Okay. And look at this. This complete angle is 90 and a part of this is 90 minus alpha. So the remaining part will obviously be alpha and this part is 90 minus alpha by the same logic. So I am using just the angle sum property here. Now what can I say about these two triangles? Let me say DAN, triangle DAN is similar to, so I went from alpha to 90 minus alpha, then 90. So alpha 90 minus alpha, then 90, that means BDN, right? This is the correspondence in this similarity. Now I require DN square, so I will use DN from this side and I will have to take BN. So DN by BN is equal to, I will have to use this DN, so I am using AN from this, AN upon DN. Now cross multiplying, I can say DN square is equal to AN into BN, right? And now I require DM here, which I can simply replace BN by DM. So DN square is equal to AN into BN, I am replacing by DM, so into DM. And the second part is, hence second part is proved, right? So I used basic similarity to prove these two parts. Okay. In this figure, ABC is a triangle in which angle B is greater than 90. So this angle here is an obtuse angle. AD is perpendicular to CB. Okay, this angle is 90. Prove that AC square is equal to AB square plus BC square plus 2BC into BD. So if I just apply Pythagoras theorem, by Pythagoras theorem on triangle ADC, which is a right angle triangle, I can say AC square is equal to AD square plus DC square, right? Now DC consists of two segments, DB and BC. So what can I write here is DB or BD plus BC whole square. Now let me open it. AD square plus BD square plus BC square plus twice of BD into BC. Okay. Now look at the right hand side. I require AB square, BC square and 2BC into BD. So I require this also. I just don't require this portion, AD square plus BD square. So fortunately, if you look at triangle ADB, this is another right angle triangle, and AD square plus DB square will nothing be but AB square. So I can simply replace it by AB square, and rest of the terms I will write as it is. Hence proved. Now if you want to know how did I replace this by this, you need to focus on triangle ADB, because angle D is 90 degrees. So AB square, that is hypotenuse square, will be equal to AD square plus DB square. This is the replacement I have done here, right? So this part is proved. Okay, right? So the triangle that I am talking about here is this one, ABC, where this is an acute angle, and I have dropped a perpendicular AD here. Okay. Now here I need to prove AC square is equal to AB square plus BC square minus twice of BC into BD. So let me check what is AC square in this right angle triangle. It is equal to AD square plus DC square, right? What I have done here is I have just applied Pythagoras theorem in triangle ADC. Alright. Now AC square is equal to AD square minus DC square. So if you look at this expression, I do not require DC square, although I don't require AD square also, but let me first manipulate this DC, because I can do it easily. Why? Because DC is nothing but BC minus BD. DC is nothing but BC minus BD. So make this replacement BC minus BD and then whole square. You see, BC, BD I require. So I think this should give me the desired result after a little manipulation. BC square plus BD square minus twice of BC into BD, right? Now look at this, AD square plus BD square. AD square plus BD square in this triangle will give me AB square. So let me club these two terms and write them as AB square, rest of the terms as it is. Hence this is proved, this result is proved. Okay, so I have used Pythagoras theorem on this triangle, that is triangle ABD, and written this result. Okay, and I used Pythagoras theorem on this triangle also. So this was just a simple application of Pythagoras theorem, right? But if you would notice, this will give me certain important results. Okay, so I'll combine these results to prove some of the theorems in upcoming questions. So although it looks a simple result, the previous one and this one, but when they are combined with each other, they will give an important theorem to us. Okay. Now in question number 5th, AD is median of triangle ABC, okay, and AM is perpendicular to BC. Prove that AC square is equal to AD square plus BC into DM plus BC by 2 whole square. Now look at this. This question is just the application of the questions that we just did. So if you have listened to those questions carefully, there is nothing extra that I am going to do here in this question. Now see, AD being the median, AD is the median. So what I can say about BD and DC, these are equal, right? BD and DC are equal. So if I want to change BD into DC or DC into BD, I can do that, and they are half of BC. So if I want to replace BD by BC, so I'll replace it by BC by 2. Okay. Okay. So you can see a similar thing here, BC by 2, BC by 2. Okay. Now look at this triangle ACM. In triangle ACM, can I write AC square is equal to AM square plus CM square? Yes, because I have just applied Pythagoras theorem in this right angle triangle ACM, right? So now what can I say about CM square? CM square is a combination of DM and CD, right? So I'll write it as AM square plus CM I am breaking into DM and DC. So I can write it as AM square plus DM square plus DC square plus twice of DM into DC. Okay. Now see, DC I can always replace by BC by 2. Okay, that is what I am going to do here, so that I can create BC into DM. You can see, right? And DC square I can replace by BC by 2 whole square. So these two expressions I can get through these two expressions by just replacing DC by BC by 2. Okay, you can check it yourself. Now AD square, can I create AD square using these two? AM square plus DM square, AM square plus DM square is equal to AD square. Yes, because right angle triangle AMD, in right angle triangle AMD, AD square is equal to AM square plus MD square. So this is what I am going to do here. I will replace AM square plus DM square by AD square. So AD square, I am replacing DC square by BC by 2 whole square. Okay, plus I am replacing DC by BC by 2. So this 2 will get cancelled and it will give me DM into BC here. So the first part is proved. First part is proved. Okay. And similarly, I'll go for the second part, and then for the third part, I don't have to do anything extra, because if you notice, if I add first part and second part's result, I'll get the third part, because BC into DM is getting cancelled. Okay, if I add these, right? So let's go for this second part. Now in this triangle ABM, this is on another right angle triangle here. What will be AB square? AB is opposite this 90 degrees. So AB square will be equal to BM square plus AM square. BM square plus AM square. So what can I say about BM in relation with BD? It is nothing but BD minus DM. So BM is equal to BD minus DM. Why am I manipulating it like this? Because I require DM in my final result, but I do not require BM. So I will convert it into BC somehow. How? If I know BD, BD can be simply replaced by BC by 2. BD can be simply replaced by BC by 2. So that is why I am breaking BM into BD minus DM. So AB square will be equal to BM, that is BD minus DM squared plus AM square. So it is equal to BD square plus DM square minus twice of BD into DM plus AM square. right? Now look at the desired result. AD square I require, right? I do not have AD square here, so I need to create it. I require BC by 2 whole square. So what can I do here is, I can simply replace BD by BC by 2. So I can write it BC by 2 whole square. BD is nothing but BC by 2, right? DM square I do not require. Now in here, twice of BD into DM. So BD is nothing but BC by 2. So if I replace this BD by BC by 2, 2 will get cancelled here and it will give me BC into DM, right? Now look at these two remaining parts, DM square and AM square. DM square and AM square will give me AD square, right? Because AMD is a right angle triangle with AD as hypotenuse and AM and MD as other two sides. So this combination will give me AD square here. Now look at this, if this is your desired result or not. AD square BC by 2 whole square minus BC into DM. AD square BC by 2 whole square minus BC into DM. Hence, second part is proved. Now for third part, I already told you, you do not have to do anything. Just add the result that you got here for AC square and the result here that you got for AB square. So for third part, I am adding AB square plus AC square, right? AB square is this, BC by 2 whole square plus AD square minus BC into DM. And what was AC square? AD square plus BC by 2 whole square and then plus BC into DM. So BC into DM, as you can see, can be cancelled. Now if I club remaining part, 2 AD square plus twice of BC by 2 whole square, and is this the format that we require the result in? 2 AD square BC square by 2. So I got 2 AD square, let me open this bracket, 2 AD square plus 2 into, this can be written as BC square by 4. Now this can be cancelled and this is the desired form, 2 AD square plus BC square by 2, right? So AB square plus AC square is equal to twice of the median squared plus half of BC square, half of BC square. Okay, this is another important theorem which you have to keep in mind from the perspective of competitive examination if you are going to take NTSE, etc., right? And the name of this theorem is Apollonius theorem. Which gives us a relationship between the length of sides and length of median. Okay. Now prove that the sum of the squares of the diagonals of parallelogram is equal to the sum of squares of its sides. So if I have got this parallelogram A, B, C, D and diagonals are BD and AC. So what I need to prove here is that sum of squares of diagonals, that is AC square plus BD square, it is equal to sum of the squares of its sides. So sum of squares of its sides means AB square plus BC square plus CD square plus AD square, right? This is one of the ways of thinking about it. Other way you can think about it is AB square is nothing but CD square. So I can club these and write them as 2AB square. AD and BC are equal. So what I can do here is I can write 2BC square, right? So this is how I can prove it. I can prove this result or this result and it will be fine because both are same. Now if you notice, in a parallelogram, in a parallelogram, diagonals bisect each other. So this portion is equal to this portion and this segment is equal to this segment here. Now let us name this point as AM. So what can you say about AM in triangle ABD? What can you say? What is this line AM in triangle ABD? Is this a median? Yes, it is a median. So AM is median for triangle ABD. Okay. So can I say that AB square plus AD square, AB square plus AD square is equal to twice of AM square plus BD square by 2. Can I say this? See, if you notice this result, AD is median in this triangle ABC. So what did I get as my final result? That AB square plus AC square, the sides from the joining point of these sides, the median is dropped. So AC square plus AB square is equal to twice of the median square AD square plus half of the opposite side square. So here what I have done here is AM square is median, yeah, right? AM is median for this triangle ABD. So if I do AD square plus AB square, it will be equal to twice of median square, that is AM square, plus half of BD square. I hope you have understood this. Now you see, AM is nothing but half of AC. AM is half of AC, right? Because the diagonals bisect each other. So by that property, AM is equal to MC. So AM is half of AC. So I can replace AM square by AC square divided by 4, right? So let me do it here. So twice of AC square by 4 plus BD square by 2. Now if you cancel these, you will get AC square plus BD square by 2. Okay. And here I have AB square plus AD square. Now if I multiply this 2 on this side, twice of AB square plus twice of AD square will be equal to sum of squares of the diagonals. Now twice of AB square can be written as AB square plus CD square, because AB and CD are equal, and twice of AD square can be written as AD square plus BC square, because AD and BC are equal, and it is equal to AC square plus BD square. This is the desired result. Okay. So I just used the theorem or the result that I proved in the question above to prove this. If you want to use this result as it is, you can also say by Apollonius theorem, right? So by Apollonius theorem. And even if you don't want to use this result, you can prove this result here in this triangle itself, okay, as I have done here, by dropping a perpendicular, then taking two triangles, and you can prove this result, that AB square plus AD square will be equal to twice of AM square plus BD square by 2. Okay, this result can always be proved because we have just proved it in the previous question, right? Now if D is a point on side BC of triangle ABC, such that BD by CD is equal to AB by AC, prove that AD is bisector of angle BAC. So We studied about internal angle bisector theorem in this exercise itself, where we had the angular bisector AD and then we proved this result. Now this is just the converse of that result, that it is already given that AB by AC is equal to BD by DC. Then I need to prove that this angle here is equal to this angle, right? I need to prove these angles are equal. Okay, so how can I prove that? So there are multiple ways to prove this, but let me do a little construction here. I am extending this side BA. I am extending this side BA and then joining it with C for them to meet at M such that AM is equal to AB, such that AM is equal to AC. Okay, this is what I have. Okay, so the construction that I am doing here is draw, or we can say extend BA till M such that in such a way that AM is equal to AC. When I do that, this triangle here becomes an isosceles triangle. So this angle alpha is equal to this angle, angles opposite equal sides. Okay, so what I am trying to do here is, what my endeavor is, that I need to prove this angle equal to this angle. So I have done a construction here that I have extended BA till this point M in such a way that AM is equal to AC. So I have just extended this side BA and taken AM equal to this AC and then joined CM, joined CM. Okay, now it is a 10-second task for me. So let us understand how it can be done. Now see, as per given condition, AB by AC is equal to BD by DC. So if I just replace this AC by AM here, can I say AB by AM is equal to BD by DC? Why? Because AM is equal to AC by construction. So if I say this, AB by AM, that is this segment by this segment, is equal to this segment by this segment, then by converse of BPT, can I say AD is parallel to MC? Yes. So AB by AM is equal to BD by DC, right? Hence AD is parallel to MC by converse of basic proportionality theorem. Now once I prove that these are parallel, this angle will be equal to this angle. Why? Because AD is parallel to MC and AC is my transversal. So this angle will be alpha, because these are alternate interior angles, and this line is parallel to this line. So this angle here, will be equal to alpha. Why? Because these two angles are corresponding angles and these two angles are alternate interior angles. So I am writing alt int here, alternate interior angles, and these two angles are corresponding angles, right? So I have just proved that this angle here is equal to this angle. So AD is bisector of angle BAC. Hence AD is bisector of angle BAC, right? So it is important that you understand the concept here, right? I hope you can write the little steps yourself, that this is the construction that I have done. Now this ratio is equal, hence these lines are parallel by BPT. Once you know this, now you just have to write that this angle, angle DAC, is equal to angle ACM because these are alternate interior angles, and angle BAD is equal to angle BMC because these are corresponding angles. Once you write this, now you know that this angle is equal to this angle, hence AD is the angular bisector of angle BAC, right? Now Nazima is fly fishing in a stream. The tip of her fishing rod is 1.8 meter above the surface of water. So this is the tip and this is above this surface of water, and this is 1.8 meter, okay. And the fly at the end of string rests on the water 3.6 meter away. So this distance here is 3.6 meter. And 2.4 meter from point directly under the tip of the rod. So if I join this, this is the point directly under the tip of the rod, and this distance is 2.4 meter as it can be seen in the figure. Assuming that her string from the tip of her rod to the fly is taut, that means there is no sag, there is nothing like this, it is completely straight, right? How much string does she have out? If she pulls in the string at a rate of 5 centimeter per second, what will be the horizontal distance of the fly from her after 12 seconds, right? So the first thing that I need to find out is the length of the string that is out, right? There may be a string on the equipment, right? I am just talking about this string that is out to catch the fly. So I can simply apply Pythagoras theorem on this triangle, right? So what can I say about length of string? If let us say this is AB and this point is D, so AB square is equal to AD square plus BD square by Pythagoras theorem. So AB square is equal to 1.8 squared plus 2.4 squared, right? So to simplify these kind of calculations, I have already suggested that you memorize the squares up to 25. Otherwise, in these calculations, you can always try to take something common, okay. So from here, you can write this as 18 by 10 squared plus 24 by 10 squared, right? So now if I take 6 by 10 whole square as common, then what will I have inside? 3 square plus 4 square, okay. So if you know this, then it will be 36 by 100, and 3 square plus 4 square is nothing but 25, right? Then it is 4 9s are 36, so 9 meter. Meter is AB squared, right? So what will be AB or length of string? It will be square root of 9, that is 3 meter. This is length of string out, 3 meter, right? Now the second thing that I need to know is, if she pulls in the string at a rate of 5 centimeter per second, what will be the horizontal distance of fly from her after 12 seconds? So 5 centimeter per second, 5 centimeter per second, after 12 seconds, she would have pulled in 12 into 5, that is 60 centimeters of the string, right? So the string left out now is equal to 3 meter minus 60 centimeter, that means 3 minus 0.6 2.4 meter. See, length of string out is 3 meter. After 5 seconds, she would have pulled in 60 centimeter. So now the length of string out is 2.4. Earlier, what was the situation? This was the length 3 meter that was outside, and here it is the fly. Now she started pulling it in, right? So this fly will come here somewhere, because this new length outside, this is the string and this is the new length of the string that is outside now. So it is equal to 2.4 meter. And what was this vertical distance? This was 1.8 meter, right? And what was this distance here? This distance was, I am talking about this triangle here. So this distance was 2.4 meter, right? Finally, I'll have to add 1.2 in my answer. Okay, so what I am trying to find out here is this distance, and then I'll add 1.2 in it to find the distance of fly after 12 seconds from her. Okay, so now to find this distance, I just have to apply Pythagoras theorem in this triangle. So this distance, or the required distance, is equal to 2.4 squared minus 1.8 squared square root, right? So which is equal to, this is again, this can be written as 24 by 10 squared minus this can be written as 18 by 10 squared. So you can take 6 by 10 squared outside from this. Okay, it is still inside the radical sign. So here I'll have 4 square minus 3 square. Okay, so 6 by 10 will come outside, and 4 square minus 3 square, 16 square minus 4 square is 16, 3 square is 9. So 16 minus 9 is 7. So I'll have square root of 7 outside. Now this will be the distance now, and if I add 1.2 in it, I'll get my answer. So this is equal to, this is 0.6 into root 7 plus 1.2. Now what is root 7 approximately equal to? We know that root 4 is 2, root 9 is 3. So root 7 will be 2 point something, right? So it will be equal to 2 point, let us say 24 square is 576, 25 square is 625, 26 square is 676. So it will be around, let us say 27 approximately, right? So what you can do is, you can multiply 0.6 with 2.7 and then add 1.2 in it. So finally what I have to do here is, if I take 0.6 common, I'll have 2.7 plus 2 here. So 0.6 into 4.7 is my answer. So 2.82 approximately is my answer for the distance of fly after 12 seconds from her. Okay, so earlier this distance was 3.6 meter. After 12 seconds, when she started pulling in the string came somewhere here. Okay, earlier it was of the length 3 meter, now it is 2.4 meter. This height is 1.8 now, and if you calculate this distance, you just have to add 1.2 in it to find the new distance. So that is what I have done here, and the distance here is approximately 2.82 meter. Okay, so this is about this exercise. Thank you.